Hello everyone, I am Rakibul from SVC. Today I am going to discuss about different scopes in civil engineering. So let us start. First, what is civil engineering? Civil engineering is the oldest, broadest and simple of the various engineering fields. It is mainly related to planning, analysis, design, construction and maintenance of buildings, roads, bridges, dams, tunnels and other structures by the use of physical laws and mathematical equations and theory of mechanics. So what is a scope of different fields of civil engineering? It consists of surveying, structural engineering, geotechnical engineering, hydraulics and water resources, transportation engineering, environmental engineering, construction planning and project management, earthquake engineering, remote sensing and GIS. So first, surveying. It is a science art of map making. It mainly deals with various types of measurements and plotting of maps plans. Unless maps are drawn, no development work and construction can be undertaken. Earlier, conventional traditional and instruments used for surveying are chain, tape, leveling instrument, etc. Modern instruments are distance meter, total station, theodolite, etc. So, common instruments used in surveying: chain, tape, compass, auto level, theodolite, total station, GPS, drones, as you can see in the figures. Classification of surveying. Plane surveying. In this type of surveying, the effect of curvature of the surface of Earth is not taken into account. Therefore, plane surveying is adopted for small areas and the degree of accuracy of plane surveying is relatively low. Geodetic surveying. In geodetic surveying, the curvature of the Earth's surface is taken into account. Geodetic surveys are carried out for large distances and areas with high degree of precision. India's Survey of India, a government department, undertakes the work of geodetic surveying. Structural engineering. It mainly deals with analysis and design of various structures like steel structures and concrete structures. Steel structures, trusses in industrial buildings, towers, etc. Concrete structures, buildings, bridges, dams, etc. Analysis, it consists of three things, that is analysis, design. Analysis, assessing or determining the internal forces or stresses developed in structural components of any structure due to applied load is called as analysis. For example, structural components in buildings are beam, column, etc. Design, fixing or finding the suitable dimension, breadth, depth, length, etc. for structural components of any structure using various methods is called as design. Example, load acting on a structure is ultimately transferred to ground, soil through beams, columns, foundation, etc. When the load acts on the structure, the various components are subjected to internal stresses of a resistance to applied load. Structural engineers design steel, concrete or timber framed structures such as tall buildings and towers, bridges, dams, retaining walls, foundation, stadium. As you can see in the figures, the following are the uses of structural engineering: analysis and design of dams, bridges, stadiums, auditoriums, multi-story buildings, analysis and design of power generation stations, analysis and design of steel industrial structures, repair, rehabilitation, and maintenance of structures, design of nuclear power plants, design of structural reinforcement for different types of structural components. Now we will go for geotechnical engineering. It mainly deals with the study of soil, its types of soil and their properties. Soil properties may change from place to place, depth, layer to layer, to depth even in the same place season to season. Any building, bridge, dam, retaining wall, etc. consists of components like foundations. The foundation is laid from a certain depth below the ground surface till a hard layer is reached. Geotechnical engineers analyze the soil to determine its sustainability to support extreme loads. Proper geotechnical engineering is essential for a safe and secure structure. Following are the uses of geotechnical engineering: to assess the quality and strength of soil or rock, to construct civil engineering structures, to design retaining walls for soil retainment, to decide type of foundations for different type of structures, for the design of roads for transportation facilities. Now let's go for hydraulics and water resources engineering. Hydraulics, as we know that water is very important need for all human beings. It mainly deals with study of mechanics of water and its characteristics like pipe flows, open channel flows, dams, irrigation, hydropower, etc. Application determination of fluid properties such as density, water pressure, vapor pressure, etc. Design of valves, pipes, gates, etc. Design of hydropower system, etc. Water resources and irrigation engineering. It deals with tapping of storage of water and supplying water to agricultural fields for cultivation, for crop cultivation, to drinking purposes and to other domestic industrial uses. Hence, suitable water resources are identified and it is stored. Identifying, planning, building water retaining structures like dams, tanks, and carrying stored water to needy area is known as water resource engineering. Irrigation, artificial supply of water to crops by different methods, drip, sprinkler irrigation as irrigation. The important basic human needs, that is water and food, are taken care by the irrigation engineering is directly. Following are the uses of fluid mechanics, hydraulics and water resources and irrigation engineering. To record the total discharge of water from rainfall from catchment area, to design the reservoir capacity to store the water, design of hydroelectric power plants for generation of electricity, design of pumps and turbines, design of weirs or dams, as you can see in the figures. Transportation engineering. It plays a very important role in economic development of country. It mainly deals with study of existing transportation system and the improvement for safe drive. It mainly includes design, construction, and management of roads, railways, navigation, and air routes. The various modes of transportation are roadways, railways, airways, and waterways. Traffic management, including traffic signals, number of lanes, parking facilities, and curves, are also part of transportation engineering. The following are the scopes of transportation engineering. It involves planning, design, construction, operation, and maintenance of transportation facility. Planning and design air, of an airstrip, runways, roads, harbors, and railways. Maintenance and graduation of harbors, airports, railway system based on requirements. It contributes economic, industrial, social, and cultural development of any country. Design of traffic signals for control of traffic, etc. As you can see in figures. Now let's go for environmental engineering. This is an important branch of civil engineering which covers both water supply and sanitary engineering. The importance of clean environment was felt with the rapid growth in population and growth in urbanization and industries. The science of civil engineering deals with the subject of tapping water from different sources, testing its quality, purification processes, and distribution of water to the consumers. Similarly, the environmental engineering encompasses the subject of treatment of waste which originate from different sources and deals with the removal of harmful substances in these waste by different processes. The impact of waste originating from industries is felt by living organisms if such waste contain toxic substances. The central government as well as state governments have enacted laws for protecting of different protection of environment needed for the safe living of human beings. The following are the scopes of environmental engineering. Involves collection of water, purification and supply for drinking, wastewater collection, treatment and disposal, air pollution control and treatment, solid waste management and control, e-waste management, control and treatment, construction waste management and control. Construction planning and project management. Construction planning. It deals with different types of construction of structures like buildings, roads, bridges, etc. Construction of underground tunnels using modern equipments. Construction of floating structures. Earlier days, only manpower is utilized for construction, but development of new technology, that is manufacture of new machineries like cranes to lift weight, painting machines, plastering machines, concrete or tar laying machines have made the construction easy and faster. It mainly includes excavation of soil, construction of foundation, concreting, finishing, etc. with different techniques and methods. Project management. Planning for construction equipment and machinery for construction project deals with planning, scheduling, and execution of construction activity related to a project. Comprises of man, material, time, and money management. Emphasis will be on new construction practice such as precast construction and pre-stressed construction, sanitation, material utilization of marginal materials, etc. Now, following are the scopes of construction technology. Planning for construction equipment and machinery for construction project deals with planning, scheduling, and execution of construction activity related to a project. Comprises of man, material, time, and money management. Emphasis will be on new construction practice such as precast construction and pre-stress construction, safety of man and material, utilization of marginal material, etc. Construction of underground tunnel using modern equipments. Now, earthquake engineering. An earthquake is a sudden and rapid shaking of ground due to a passage of vibration beneath caused by transient disturbance of elastic or gravitational equilibrium of rocks. The scientific study of earthquakes is called seismology. Earthquakes are measured using observation from seismometers. Seismic waves are recorded on instruments called seismographs. The time, location, and magnitude of an earthquake can be determined from the data recorded by seismograph stations. Earthquakes with magnitude of about 2 or less are usually called micro-earthquakes and generally recorded only on local seismographs. Events with magnitudes of about 4.5 or greater are strong enough to be recorded by sensitive seismographs all over the world. Great earthquakes have magnitudes of 8 or higher. As you can see, we can use civil engineering for making earthquake-free construction. Now, remote sensing and GIS. This is one of the new fields. The improvement in space technology, ability of GPS enhance the scope of geographic information system. Good mapping techniques helps us to get required information accurately and quickly to effectively manage and monitor the available resource for optimal use. GIS is an high-tech equivalent of map. It represents some means to locate ourselves in relation to world around us. It deals with measurement, mapping, monitoring, and modeling of geographic information around the world. Remote sensing and GIS. Basically, it uses the satellites and information through GPS, etc. So that's it for today. Thank you for watching.